Hello, everybody, and welcome to Friday if you're in my part of the world, to Thursday everywhere else. It is that time again. Today we are going to get stuck into a bit of a live discussion. But what the duck is ineffable cryptography? Now, let's get started, and I am going to welcome my wonderful guest for the day to the stage. Let's turn the handles, crank the wheels, and welcome, hello, Mike. So a team who have not met me before or not encountered this, my name is Laura Balmain. I love all things application security, part software engineer, part AppSec nerd, and just general person who likes to collect stories and talk to really amazing founders and engineers. And that's where Mike comes in. So Mike, tell us about you. Who are you?
I am one of the co-founders of Tide Foundation. In a previous life, I've worked at the University of Illinois in the States, came back to Australia, built a software development and go-to-market agency.
As you do.
As you do. Sold that to a bigger agency and then finally came out to play because it was too much fun building other stuff for other people. I wanted to come out and build my own, and now I'm finally doing that.
Right, and that's why you're here, right? So Mike isn't just building another agency. Mike is doing something that just, when I heard about this team, the nerdy bit of my brain went, what on earth is this? It's hitting those bits that mostly terrify me. So you say the word cryptography to me, and mostly that 17-year-old maths nerd in my head just cowers and hides. So Mike, what are you building?
Although we're building something and operating at a very low machine level, if you want to think about it that way, in terms of cryptography being the very foundation of anything secure on the internet. Without cryptography, nothing is private, nothing is locked, nothing is secure.
Mm-hmm.
We're solving a problem that, if we do our job right, makes building a non-issue, makes the worry of having to secure something that you build no longer your responsibility as a developer.
So this sounds like magic to me. So let's jump into this, Mike. Let's get to this. So the product, as I understand you, it's open source, right? You are doing. So I'm going to use lots of terms I'm not familiar with, Mike. So I'm going to want you to jump in and correct me because I'm going to make lots of mistakes. The phrase that came out with all of this was ineffable cryptography, which firstly, I failed at 20 times this morning practicing that phrase.
Say it 3 times fast.
Exactly. No, can't do it. Actually, I think you probably summoned something at this time of year. So what is this open source project? What does it let developers do?
So again, going back to what I was saying, where the foundation of cybersecurity or security in the internet is cryptography. We all use cryptographic libraries. We may not even realize it because they're already embedded somewhere in our software supply chain. Nothing's locked without it. But one of the underlying principles we rely on is a 140-year-old principle called Kerckhoffs's principle, named after Kerckhoff, a Dutch cryptographer, mathematician, which says that the security of a crypto system should be intact, even if the entire system is public knowledge and available to your adversary. Everything except the key. So you could share this algorithm on how something is locked as long as the key remains secret.
Amazing. Okay, cool. So even that just breaks it down. I didn't know about Kerckhoff, so there we go. Salutes to you, Kerckhoff, 140 years ago.
Yeah.
So you're helping make this reality then?
So we are taking that principle and taking it to the extreme, where today, intuitively, the owner or the operator of what's locked behind that key needs to hold that key, needs to secure that key, needs to put it somewhere. Today, that key has to live somewhere on something, and someone always has access to it.
Absolutely. I've even got even in the physical world, this is true, right?
Exactly. Let's not talk about the fact that your locksmith doesn't need that key. It doesn't matter.
Dreams are free. Dreams are free.
So the point of ineffable cryptography, as kind of the name suggests, is that there are some things that are too sensitive to exist, some things that are too sensitive to trust in the hands of anybody, even the owner of what's locked behind that key, because the owner can lose that key. The owner can have the key stolen.
Yeah.
The owner can make mistakes. So the point of ineffable cryptography is to take Kirchhoff's principle to the extreme and to say, not only are we going to keep the algorithm as public knowledge, but we're going to make sure that no one has access to the key. The key remains
that's cool.
out of reach of everybody, including the owner, so that it can't be stolen and so that it can't be used outside of how it's supposed to behave.
Awesome. Okay, so just going back to like, you know that thing where you're talking about something and it pulls up those long forgotten lectures from university, and somebody was drawing Alice and Bob on things, and the root of all problems in crypto seemed to be that Alice and Bob were really bad at handling keys. So you fixed Alice and Bob. That's amazing.
That's the idea. Yeah, and
cool.
To bury that so deep that it's there, you know about it, you can verify, and that's the most important part, is not having to trust that key to anyone, so that the root of your entire security mechanism doesn't sit somewhere that you blindly have to trust on a particular server with a particular IT team, or all over your software or vendor supply chain. You can put it somewhere where you can verify the integrity of the security. You can verify that security is intact. You can see transparency around every time that key is used and who is used by, and
nice.
without having to circumvent that process.
Awesome. Well, the security nerd in me is very happy because I love all these ideas of transparency and audit, that repudiation part of it all. But there's still the engineer in me is like going, but how? So how do you do this?
So the concept of no one holding the key is made possible through a combination of new approaches to existing fundamentals. The way that we make sure that no one holds the key is for that key to only ever exist in pieces from the moment it's born to the moment it is no longer used, and even while it's in use. So while that key is decrypting, being used to authenticate, to sign, to do whatever it needs to do, but always in pieces, and have those pieces live on different servers with different organizations managed by different teams, so that to the greatest extreme you can, making sure that no one can ever compile that key. The key never comes together. And that sounds like magic, but it's not. It's mathematics.
Well, my brain is delightfully ironic with this, because my brain just went, like in Harry Potter with the Horcruxes, which dates me horribly. But it's kind of, if my brain has reached for something it knows, then there's a familiarity there with it. Yeah. Okay, cool. So we're distributing key fragments to nodes, some places, and then never in the same place at the same time.
Correct. And they never come together, even when they're being used.
Wow. That sounds like a lot of organization.
6 years of cryptography R&D and validation with multiple universities and others, and then taking the science and implementing that in code.
Wow.
But yeah, it all makes sense when you thread it together, and it's all available for scrutiny, which is obviously important.
Look, I've got a whole list of questions here that I'm going to go through with you, but I've got one that's just like really like foghorn in my mind over this, because so the system that my brain's thinking about in parallel to this, other than Harry Potter, is DNS, right? Well, the DNS is fragmented across multiple servers around the world, and that's how we have the resilience in it. And so there's a similarity there in terms of the distribution of the key fragments. Is there any, from a disruption point of view, how resilient is this to nodes being unavailable or not being able to be contacted?
That's an awesome question. So unlike, for example, when you're relying on one big vendor that, I don't know, let's pick on AWS, since half the internet went down last week.
Yeah, hookups, AWS, we feel you. That was a bad day for all of you, I'm sure.
It wasn't a good day. The point of having a decentralized network is that you're not reliant on one vendor, one geography, one jurisdiction, one anything. The way that the cryptography works is, let's say, two kind of academic things kind of weave together. One is called multi-party computation, which is instead of performing an operation or a task on one server in one place, where if that place is compromised or malicious or down, you're fully reliant on it. Doing that process in pieces, where a swarm of servers are performing that operation, all doing a small part of that process, sending something back, meaningless puzzle piece, and then bang, you have the final artifact.
Nice.
But to make sure that you're not reliant on now multiple servers instead of just one, that you're putting all your energy into, there's something called threshold cryptography, where you only need a certain availability, a certain threshold of those nodes to be available in order to perform that operation. So we have a built-in redundancy in the mathematics, in the model, so that 30% of this global network can disappear overnight and it won't impact performance or security. And there's not one IP address or one domain that you can attack or that falls over that will compromise the servers.
Wow. So theoretically, the more successful what you've built is, and the more used and distributed it is, the more resilient it becomes. Wow, that's really cool. Oh, awesome. Okay. All right. So for those who are meeting me for the first time, I do AppSec a lot, but I also write code, mostly terrible Python these days. So one of the things that I like to ask when we get somebody who's building stuff is like, what does this look like as a developer? How do I use this thing? Is it, do I need to be a deep crypto nerd, or is this something that I can just plug and play? So talk us through it, Mike. If I was to adopt this today, what would I need to do?
We've gone to pains to make sure that all of the complexity under the hood is something you can verify, but not something you have to worry about, not something you have to deal with. So the SDKs that we've created and the documentation, which continues to improve over time with more developers working with it and giving us feedback and contributing, is to make sure that it's straightforward. You don't have to manage the 20 simultaneous API calls, that the SDK does it for you. So drop in the SDK in your language, a few declarations at the top of the page, a couple of imports, and the SDK will communicate with the network for you in order to authenticate a user, to decrypt a sensitive piece of data, to sign an authorization, to unlock something inside of your platform.
Nice.
So I can show you an example if you want.
Oh, heck yeah. Oh, look, demo. Let's do it.
Okay.
See if the magic wizards behind the technology work. We can do this. There we go. I'm going to click the button. Clicking it. There we go. Oh, look. There we go. We've got a medium post. There we are. Oh, look. It's a TLDR. Who doesn't love a TLDR?
That's pretty much it. The rest of the I can share the link, but the rest of the article just talked about the strategy, the philosophy, how it works behind it. But as a developer, you drop in a line of code, a button in HTML, declare something up top. There's a couple of imports.
Nice.
You're using the service.
Yeah, I'm one of those people who sees a recipe online and skips the 20,000 words of backstory to get to the TLDR. So yeah, I appreciate you. All right, so we've got our lines. What's this look like?
Why don't I give you a demo?
All right,
probably the most boring demo you've ever seen. And
I respect a good boring demo. If there was Twilights and Unicorns, we're not doing a crypto talk. That's what it looks.
All right. So right now I'm about to log into a CRM.
Wow, there we go.
I can use passwordless, but let's keep it as boring as possible.
Yep, there we go.
I think I entered my password.
I don't think your password's very long, Mike.
It's not that long. Did you hear from the clicks? Did you figure it out?
Yeah, almost.
And that's the end of the demo.
Wow. Ta-da. Okay, all right. So can we do that again? But can you show me what that's doing? Can we see the calls that it's making?
Yeah.
Sweet.
Let me open Developer Tools.
Yeah.
Over here.
That's how you know you've got an engineer on a call. You're like, all right, that looks lovely, but show me what the calls are, please.
Okay. So keep a note here. I've got the network tabs open.
Yeah.
Over here, instead of seeing a single green line, which is a single API call, where typically your web app would be sending an obfuscated version of your password for you to compare against the password you've got stored in your server. So you would typically, in your identity and access management system or whatever you're using, have a list of everyone's usernames and passwords, or you're outsourcing that to Okta or someone else to do for you. But effectively, there's a directory of everyone's username and password, which is obviously problematic because it means that someone somewhere can access that entire repository. Now, again, keep a note of that, and you'll see very quickly. Try to slow it down.
Oh, what is that? Oh my goodness!
20 simultaneous API calls going to talking to 20 different servers, all performing a small part of that authentication process, sending a puzzle piece back simultaneously. And I had cryptographic proof someone entered that password incorrectly and a signed access token that allowed me to get it.
I mean, you know, like kudos. For those who are watching at home, you're like, oh, but this is yes, it's not an exciting demo, but it's really interesting. If you've ever put in place something like Auth0, or you've homebrewed some form of authentication, it doesn't look like that in the development tab at all. It is really single pass, and those were fast. Those calls seem to go through very, very quickly. There's no latency from the number of calls that you would need to do that.
Because everything happens in parallel.
Yeah.
And both the sending and the response, it's super quick, and that's true for an authentication, like you saw, whether it's single factor or second factor. It's also true for encryption, decryption, for getting a cryptographic signature.
Yeah.
So yeah, it's that, and then again, this comes down to the years of effort that we put into the R&D phase to make sure that there was no latency, there was no cost to get the benefit. So we had to develop new models, new multi-party computation, new zero knowledge proofs, on top of relying on standing on the shoulders of giants. Who have developed things like Shamir's secret sharing and other things that kind of have been used conceptually, at least.
Yeah. And so you talked earlier about there being like this resilience built in through the crypto of, you only needed a percentage of the equation, and you also, you've got all these nodes. So now I can see that in action. I can see those 20 calls. How do you handle, say, network partitions or node failures? Is there imagine a catastrophic scenario. What would that look like?
So we have in the models behind each of these operations, we have what's called an honest minority assumption. So most multi-party cryptography or multi-party computation assumes an honest majority, where a few nodes might be malicious or down. We've assumed the opposite to make sure that it's as resilient as it possibly can be without sacrificing the performance that you need for something to be practical.
Nice.
And the way we do that is by using zero knowledge proofs. So basically a node who's performing a part of a process for you, holding a little piece of your key, will do something with that little piece of key. We'll send it back to you, but it'll send it back with what's called a zero knowledge proof. Proof that piece of key was used without having to share that piece of key, without having to share anything sensitive or even remotely sensitive that it was using in that process. And you can mathematically verify without getting access to the secret through the mathematics. They used the piece. They operated this correctly. I know that they did their job properly, which means I can use the puzzle piece that they sent back to me as part of my throwing this together to get the decrypted artifact or get the signed permission slip or whatever it is that I was asking the network to do. So by having this zero knowledge proof come along with the piece of work that the server did, the dealer, if you want to call it that, in your Alice and Bob kind of analogy, knows whether to ignore or to use something that the node provided. And because it's all open and transparent, a cybersecurity managed service provider can say, we've got to stop using that node. That node's been compromised, because you can tell based on the responses, the frequency, and all kinds of stuff, because that audit trail is sacrosanct. You can't circumvent that knowledge, that telemetry. So you know when nodes are non-performant, you know when nodes are acting out of turn, and you can then decide to pivot away from it and respawn the key, whatever you need to do.
This is really cool. I've got more questions, but just sort of thinking out loud for a second. This is all open source, right? All your SDKs and things people can go and have a look at. So if you are like me and you're listening to this and you're like, this is really interesting, and not saying that you need to understand every line of what they've done. They've worked on this for a long time. There's a lot of maths nerdery in this. But if you are like just gently stepping into this area, going and looking at the source code for products like this can be really a great way of understanding a bit more about what Mike's talking about. So don't be shy about going and having a look at that. I actually have a massive time and a lot of respect for security tools that are open source, not because I don't think it makes them vulnerable at all. In fact, I think it makes them a lot more resilient than most. And it takes a lot to get to the research to the point where you're like, yeah, actually, this is solid. And so it doesn't matter if we share this with you. So that's awesome. Okay. I'm going to talk a little bit about the story of this, because you didn't just like wake up one day and go, you know what, I'm going to make a commercial cryptography product. Nobody does that. I don't think anybody does that. It seems quite strange. No. So the background for this didn't come from the commercial space. It came from university, right?
Actually, it came from a completely different
okay.
Where we evolved from. So
okay.
We initially, so when I had sold my software development agency, we had a client in the pharmacy space selling connected health devices into pharmacies.
Okay.
And from a whole bunch of interactions, conversations, and some research, we ended up building an IoT marketing and analytics platform. So think of it as like a middleware where you're connecting brands, organizations who want to talk to their customers, but through real life data. So instead of browser stalking, a pharmacy chain can interact with you based on the fact that you're training for a marathon, or you're pregnant, or you're whatever, and create a more meaningful engagement with you with your consent.
Yeah, that's quite important, I think, on this one. Yeah.
And that's the evolution. The evolution of Tide and this entire approach was we had built this amazing platform. We had Kellogg's doing marketing campaigns. We had pharmacy chains using it to power loyalty programs. And as the opportunities got bigger and bigger, there was more scrutiny around the fact that Kellogg's, which was kind of the catalyst, was working with some startup on the arse end of the world, holding ridiculously sensitive information. We knew more information. We knew more about people's health than they perhaps knew about themselves from all this happening. And we had to prove to Kellogg's, who were smart enough to say, hang on, there's this thing called the GDPR coming into the fold. We could be up for fines in the billions if this thing goes awry. Yeah. And the way that we had already built this kind of separation of identity and telemetry was kind of the initial phase. But we thought, what if we take that to the extreme to prove to Kellogg's that we are not a supply chain risk. We are not a risk because we find a way to, and conceptually we say to Kellogg's, what if we were to lock the identity of anyone connecting with our platform, so us sitting in the middle of your relationship with your consenting customer, and hand them the only key? We can tell all kinds of things about them except for who they are, but they can identify themselves directly to you. We get breached, doesn't matter whether our CTO's gone rogue, whether we have been completely compromised. We have mathematically no access to that without the very explicit consent of the customer. So that was the concept. Yeah. Kellogg's then came back and said, actually, can we license that technology? Because that we're really interested in. We're sitting on this mountain of data from decades of marketing campaigns. privacy is becoming a big thing, and we're pretty vulnerable. And so that was a kind of a big pivot moment for us. The IoT marketing platform was put on the shelf, and we set to actually solve the problems that you need to do to hand a consumer a cryptographic key, which, when people can barely manage a username and password. And we first looked to the blockchain world thinking, oh, well, they must have solved this problem because none of us are cryptocurrency nuts. But thinking, well, they must have solved this problem. And then we found this world of wallets, mnemonic phrases.
No. Narrator, they have not solved this problem.
No. So because we have a Yuval on our team, Yuval being my co-founder, who is one of the inventors of voice over IP and designed the first secure VoIP protocols, is an amazing guy. We set about inventing one, and we explored a whole bunch of different ways to do that. But in the end, what we conceived of is this. This is what our research kind of was kind of framed under ineffable cryptography. How do we give someone the ability to talk to and use this key that lives in pieces without having the responsibility of holding it, without just shifting that responsibility to someone else, without handing that key back to the person that you didn't trust in the first place to manage, but without changing the user experience, without asking someone like my dad, hey, instead of managing a username and password, just store this key, download this wallet, store this key, print out this mnemonic phrase, put that in a safe, because if you lose this, you've lost access forever. So we set about solving all of those problems. Anyway, that's the long story of how we ended up going down this path, was basically to solve our problem as a software platform. How do we make sure that we can be trusted by removing the need to trust us altogether?
That's awesome. I love that there was this big aha moment. You've got one product that you're building and trying to sell, and you're realizing that this tiny niche, really pivotal component was actually the real gem in amongst it all. So like I have a swear jar on my desk, Mike. It's called the How Hard Can It Be jar, where I put $1 in every time and say, oh, how hard could that be? Was this a thing that you thought it was going to be super easy and it was harder than you thought, or were you aware up front of how hard this was going to be?
First of all, I thought you were calling me out on swearing, so I wasn't sure.
No.
I forget that I'm in public. But I think actually for us, solving the technical and mathematical challenges, even though it hadn't been done before, was not the hardest part, because of the unique skills that exist within our team.
Yeah.
The hardest part of doing something like this, particularly in the geography we're doing it from, is the lack of understanding. I would say bringing a new concept, bringing new ideas to the world, always resistance, and rightfully so. As a developer, I'm skeptical by design, by default. I don't trust anything unless I can see it. Anything that sounds too good to be true,
probably is.
System does.
Yeah.
It raises like a million red flags, and that along with the lack of support that you get in this region for what we're doing, has made it more challenging than it needs to be, but totally understandable. And these are just things that we've got to deal with when you're introducing new ideas to the world. You need to do it openly, I think, and you need to accept the scrutiny, and you need to adjust. A lot of what we've done, a lot of the changes we've made, a lot of the ways that we've been, again, trying to build the documentation is based on feedback, based on working with real developers, solving real challenges, not the ones that we're imagining ourselves,
Yeah. I'm going to come back to this at the end. I've got one more question, but I think if you are like me, there's a lot of engineers who follow me. I'm connected with lots of software folk around the world, and love you all. You're all beautiful nerds. But that's probably a nice reminder for me that one of the things that we can do as engineers is try these new technologies, not with the hope that they're magic, but the feedback that we can give and the perspectives we have. It's really hard to get all those perspectives naturally in one team. So when there's new things like this coming out, having a play, downloading the SDK, put it in one of your playground projects and just having a look at it will be really helpful. And if you have feedback and you do try out any of this technology, I'm sure Mike and the team would love to hear from you with, what did you learn, or what crazy demo did you build? Because the things we're used to now is we use these big, highly funded brands essentially selling those SDKs. But a lot of the real SDKs that we rely on and don't think about anymore don't come from that. They come from just people using it and talking amongst themselves. So it's a nice reminder that we can still do that. So, Mike, if we've got any developers listening, watching, who are using a traditional IAM system right now, so identity and access management for those who are allergic to acronyms, a bit like me, what does the migration path look like? Do you have to rip everything out and start again? Can you put it in alongside something else? If I was thinking about it, what would I need to do?
So one of the things that we realized very early on was that we needed, first of all, a kind of marquee example of how do you use this new thing? How do you use this, what we call our cybersecurity fabric, that decentralized network that allows you as a developer to, excuse the swear jar, lock shit inside of your platform with keys that no one ever holds. We needed to show, here's best practice. Here's how you use this new tool, and here's how it's going to look for you. And we chose Red Hat's Keycloak. So Keycloak is probably one of the bigger open source identity and access management systems in the world, and it's Red Hat sell it as their single sign-on product, but it's used by like tens of thousands of organizations, from greenfield startups that want to own and control their own identity system to Northrop Grumman's and others in the world where security is important for them. But for us, what was important is that it was open source, and so you could see exactly how we were taking this product and now using this new capability. And so we kind of created what we thought was going to be our flagship product called TideCloak, which is the amalgamated Keycloak and Tide. But what we found is that we got really good response from the Keycloak community, including Stian, the founder. And now all of the kind of things we've hacked on top of it are being upstreamed into the core code base so that they exist inside of Keycloak, which for us is perfect. We don't want to be entering the identity and access management space, just like we don't want to be entering the CRM space. We want to create this tool that developers who know their business, know their industry vertical, can use, and then focus on building great stuff. So for us, the best thing in the world that could possibly happen is that TideCloak, this identity immunity and access management system, as we call it, disappears from our website, and you just go take Keycloak, tick a box, and you're using the cybersecurity fabric to secure what you're doing. But Keycloak itself, which is the box we put ourselves in initially, is an amazing product. It's very comprehensive. It's like having the entire code base of Auth0 in a sense, and doing with it what you will. But it's specifically designed for to allow easy migration paths, to have two systems kind of operating in tandem and migrating from one to the other in kind of a
nice,
all using open standards, so all standard compliant.
Awesome. Well, that gives us a pretty straightforward way to start then. Awesome. This is pretty cool, Mike. Are you excited about what you're building?
I am. I have to be, because burning the camel at both ends. You need the energy to come from what you're building. But yeah, absolutely, it's.
So to ask you an unofficial question, so what's the dream with this? If you could see anything with this technology, what would it be?
Well, the fun thing for us is that if we achieve commercial success, it also means that we're building the world that we want to see. As a developer, like take that IoT marketing platform. As an individual, as someone building that platform, there's no ways I would want to have to trust my health data to some third-party company without knowing what I'm consenting to, without having control over what I'm sharing, what I'm not sharing. And I know that doesn't exist today. I know that I need to give that information over to even my doctor, and I have no idea what happens with that information. Actually, I do know. That's the problem. I know that even if there's best intentions on their end, I know where that information is going to end up.
Yeah,
that's problematic for me as a human being. that would be problematic for me if I was the platform developer having to sell that platform. So in a sense, if we're successful, we build this infrastructure, this global standard for best practice security or authority management, whatever you want to call it. And it means that we've built something that can create the internet that was intended and the internet that I would want to see. And, something where I can use an app that to care for my family in terms and know where their health data is being shared.
Yeah.
You can use an app to follow, to make sure your kid's getting safe home from school, knowing that no one else can.
Yeah, that's really cool. I'm just going to kind of bring this all together, Mike. This has been, I love it when I sit and I have a quiet reflection at the end of these calls. I'm like, yeah, I can see where I would build this. In fact, I've got some little projects that I have working on in the side at the moment that I think I might go give this a shot. I try not to do interviews with folks who are, glossy marketers who have a magic box to sell. It's not very interesting to me, but I do love technologies that come from a very wholesome place where there is a problem that, none of our solutions are solving right now. And what I love about yours the most is it is taking away that reliance on the individual human to manage any keys. We all, myself included, suck at this. It is an awful problem, and it has been a problem for a very long time. So I'm genuinely excited to hear all about this, and I'm going to be going to download the SDK and go and have a look at TideCloak myself. Mike, if anyone watching or listening this wants to connect with you or Yuval and the team or to take the next steps, I know you're going to send me some links and I'm going to post those on our social channels, but what are the best ways to contact you?
Probably the website, tide.org, TIDE.org. From there, you'll see it's not slick marketing, but you will eventually find your way to links to our GitHub, links to contact us on a variety of social media or other channels. Feel free to reach out. We have a program that we've set up now to work directly with teams that want to work with us, where they want the capability integrated into whatever they're building. And to whatever capacity we have the ability to work with. We help in that process. We explain the technology. We help with the integration. So we have what's called our Alpha program. So yeah, feel free to kind of submit some details there and meet us.
Awesome.
Yeah, that's where I'd start.
Well, I'm looking forward to seeing more of this and it getting adopted in some really interesting places, because I think that from the little view that I've had, I can see where this is going to be really, really useful across the board. So congratulations to you and the team, and not just for the cool tech, but just seemingly being nice humans while you do it. That's a nice combination. Thank you so much for your time today, Mike, and for sharing all of your wonderful knowledge. For those of you who have been watching along, thank you for joining us today. Or if you're watching this later, don't forget to contact us if there's anyone else you think we should have a chat with, or if you're adopting any of these technologies or trying them out and you learn something, do get back in touch with us or with Mike. I'm sure that we'd all love to hear your stories. Mike, thank you for joining us. Enjoy the rest of your day.
Thank you very much. Appreciate you having us on the program.
And to everyone else, enjoy the rest of your day, morning, evening, afternoon, wherever you are joining from right now. And I will see you very